All right, so today you're going to learn about BLAST. Hope you have a blast, and it has so many uses. And as I said, I would put on my CV if I were you under coursework that you've learned about BLAST, and you can use it. You might not become fully proficient on it, but at least you're going to have a pretty good idea of how to run it and how to interpret outputs, and you can have a good idea of what it's capable of and things that it cannot do, and you're going to learn why not. So I'm going to share with you the file on BLAST. Let's see, it's file 10. So there will be two files. There's the BLAST PowerPoint presentation, and then there is BLAST exercise. And I uploaded the file earlier, and I don't see it. Just a moment. Why is it not there? Okay, it's converting now. Yeah, I don't know why it's not there. Okay, there you go. All right, so you've seen that word before when we talked about alignments, and I told you the L is for local. So there will be a little bit of review and then a bunch of new stuff. So what should you learn from the class? Okay, what is BLAST? What do we use it for? You learned about BLAST 2. Because I started that way because it's simpler, and I felt it's good for you to learn about DNA and orientation and what is BLAST doing. So if you remember, it's BLAST 2, you were comparing DNA sequences, and we were looking for where do they overlap, and we had used it to build contigs. So maybe you remember that, maybe you don't, but it's when we are sequencing DNA, and you might be sequencing one strand of DNA on one fragment and the other strand of DNA of the other fragment. So it's kind of like burning a rope, right? You are starting from both ends, and eventually they meet in the middle, which would be the overlap where the two reads are the same, and then you can build your contig. So I gave you the example of BLAST 2 because it was a gentle introduction to BLAST. But we're going to use BLAST, and what we do is we uncheck that align two sequences. So you will see how that works. This part here, and I already introduced you to this earlier, but the D value is the expect value. It's kind of a big deal to know what that means. And then you don't have to know how it's calculated. If you're in math, you might go like, oh, I really want to know. I give you the formula. If you are not in math, you're going to go like, oh my gosh, what's this? I just want you to know, okay, given this formula, when you alter some parts of the formula, how would the value change? But the meaning of the value is that expect that the two sequences will be a match due to randomness. You could think about it that way. And so the lower your value, the less randomness, meaning the two sequences, they do align because they have a lot in common, not because maybe they were very short, or maybe there were like lots of repeats. So in any case, you're looking at the value, and if you're looking for a match, you are hoping for a low value. So because the low value gives you more biological meaningfulness. So meaning the two matches are not just a random match, they actually are a good match. Okay, so, and then later in this class, maybe you won't get to that, but there is something called a 6-frame translation. And I want you to know why does it do that. We're going to do an exercise on this and probably finish it on Monday. This part here, so there are lots of programs that are BLAST programs, You have to know which one to choose. And I'm telling you, you do not have to memorize. So there's BLAST N, BLAST P, BLAST X, or T BLAST X. You have to know or memorize. You just, when you go to the website, it gives you a short description of what it does. So you need to know when to use one or the other, but you don't have to memorize them, because when you go to BLAST's website, it tells you what it's aligning. You just need to know why you choose one over the other. Okay, so when you have no matches for BLAST, what does that mean? And the last part, it will also have to do with the 6-frame translation. Why can't you align? Why can't you give a protein sequence and hope for BLAST to find a DNA sequence that matches that? And you might go, well, because protein is not the same as DNA. And I'll go like, yeah, that's part of it, but it's a little more involved than that. So like you'll see that the 6-frame translation, it's done when you give a DNA sequence and you ask, if this DNA sequence was a protein sequence, what protein sequence would it be? And then you'll see there are 6 possible ones. So that's the 6-frame translation. But you can't go the other around, and hopefully you'll be convinced why not toward the end or Monday. Okay, so I mentioned to you guys about this website, NCBI. Yes, so you will see that we can do DNA to protein conversion if you think about that, but it is all, we call it in silico, meaning on the computer. We're not actually going in the lab and taking a DNA fragment and translating it to protein. It could be done, but when we are looking at sequences, we are doing this work in silico, where everything is possible, or almost everything is possible. So you are going to give a DNA sequence, and the computer is going to say, okay, if this was protein, which protein could this DNA sequence be encoding? But we don't give the computer a protein sequence and ask which DNA sequences could encode this protein. In theory, it's possible. In practice, it's crazy. All right, so I told you, remember when we ran, what's it called, muscle and cluster, and I told you EBI is the European NCBI. And here's a little bit more about NCBI, it's the National Center for Biotechnology Information. It's maintained by tax dollars. A few years ago, there was a government shutdown, and my concern at that time was like, oh my gosh, I can't run BLAST because it is maintained by tax dollars, and if there's government shutdown, we can't run it. So it's a very big luxury for me to just worry about that. But in any case, to each its own problems, right? So it's located in Bethesda, and it harbors what's called the gene bank. So when it used to be a big deal to sequence DNA, now everybody can do that because technology is so much cheaper. But and it's still, when people sequence DNA, they deposit on that bank. So it's a database that is holding nucleotide and amino acid or protein sequence information. So here's some information for 2015. I bet this graph went like woo, really like upwards. Let's just see if they have a newer one. But it started with, what is this, 1 million sequences, and these were some genomic sequences, but now this WGS is whole genome sequence. And like I said, now it's cheaper to sequence. You see how the upward, now there's more whole genome sequence than just fragments of gene sequences or genomic sequence. So the whole genome sequence would be, you sequenced all the DNA from at least the nucleus of that cell. This other one, when it was more expensive, you had to select which gene are you studying? What do you want to sequence? And yeah, it was much more selective when it was expensive. So the NCBI harbors the gene bank, which holds those sequences. This kind of curiosity. the first time, or there was a first iteration of the gene bank, they printed. And when you open this, it's just a bunch of nucleotide sequence. Can you imagine, like, oh, I want this one, and now I have to retype it somewhere. But anyway, I don't know why they printed it. I guess it's for historical purposes. And it had only 8 million nucleotides. Now, I don't even know how many zeros are in here, but there is so much information now, so much more. So the NCBI harbors gene bank. It harbors something called PubMed, which maybe you're learning about PubMed if you are in 391 or 491. You're writing your papers, so you can look for papers there. There's something called the NCBI bookshelf, which allows you to read the books, and they're free and legal. And oftentimes it's older versions, older editions of a book, but they have figures there, and many of the links that are provided in the calendar for, like, here's some background about this, if you want to read about this. Many of them I took from this free bookshelf. Finally, NCBI harbors BLAST, which you've used before. And there's more stuff, but here's like just an overview. That's your tax dollars at work. So I don't know if you can hear Nina, but you guys heard about BLAST2. What did you use it for? What does BLAST2 do? Good killing, yeah. It aligns sequences. So you guys used BLAST2 to align two sequences that you gave BLAST to align. And it aligns those two sequences, so it does pairwise alignment, and the alignment is local. So there's another tool called BLAST, which is not BLAST2. And what would be your guess? And you probably guessed this wrong, but that's okay. I just want to see, like, can you go by the logic of BLAST2 aligns two sequences? What does BLAST do? Okay, Tatiani, you picked, huh? Yes, Tatiani said it aligns against the database. So yes, and I thought you might say, oh, it does multiple sequence alignment, but no, because normally multiple sequence alignment, remember, it's global alignment, and the L in BLAST is for local. So yeah, BLAST still does pairwise, except that instead of you giving the two sequences, you give one sequence, and then BLAST is going to look at that one sequence and see, do I have any sequence in my database that matches this one that you input? So it's like, maybe you're going shopping on Amazon, and then you type some keyword, and then what the website is doing is it's looking in my million or billions of items here, do I have anything that matches your search? So it aligns sequences, still is pairwise like BLAST2, but the difference is that you don't provide two sequences, you do one, and then it looks against the database. Like, no, Amazon, you put that one in there, and then it's looking in their database, do they have something that matches the thing you're looking for? So you've seen these words before. So query is your question, right? It's the letter or the words that you enter, and then subject is it's also called the hit. It's whatever matches. So you were looking for, I don't know, bird feeder, and then Amazon comes back with all these bird feeders. So your query is the bird feeder, and the subject is all the bird feeders they have that for sale. I have another example here. As you know, I like thinking about finding your soulmate, because I don't know, that's what a lot of people are doing in your age. So let's say that there is a website where I can enter my word, my query, and I'm looking for my soulmate, and I have my priorities right. So I said, I want somebody rich. Like not Richard, just rich. Could be Richard. So this is my query, and that's the word that I am looking for. And then these are 2 hits. So the database will call these guys, we call them hits, or it will also in the alignment to show as query rich, and then subject. There's going to be this, which is in FASTA format. You know, there's Joe Schmo. He's smart, he's handsome, he's rich, and he's self-centered. And there's Prince Charming. He's a good dancer. He has a shoe fetish, and he's also handsome. So in the chat, right, which of these 2 guys will match my very deep search for a rich soulmate? Right, so I said the Joe Schmo. Yeah, that's right. So good, guys. Yeah, and this is my silly example for you enter, maybe it's an amino acid sequence, and okay, there are no amino acids that are old, but in any case, it's looking where in this sequence does it match which. And it doesn't have to actually look, maybe I should put an example here where the name of the guy is Rich, but actually that wouldn't match, because what the computer is looking for is not, does the name of your sequence match this thing? It's looking for the attributes, if they match your query. So this guy is from Cinderella, I guess. You know, he likes shoes. I like shoes. All right, so that's kind of how BLAST works. Now, sometimes you enter something. Let's say that now I decided to change my priorities, and instead of looking for rich subjects, I'm looking for intelligent. And then I get, okay, my database is very poor, only has 2 guys. So which of these 2 will it match? So right now, intelligent, I know you guys said, oh, this one says smart. Good thinking. But if it was Amazon, it probably would know to look for synonyms. But if this was protein sequence or DNA sequence, it wouldn't match either of them. And now I'm desperate, right? My goodness, are there no intelligent subjects in the world? So is my search for intelligent life is it gonna fail? So don't despair. That doesn't mean that your keyword doesn't exist. It just means that it's not in the database. So this silly example is just to say that if your search didn't match anything, it doesn't mean that that search doesn't exist. It just means there's not upload in the database yet. So imagine that this was some DNA sequence. It said ATCs and Gs. And it was a sample that I extracted, like when I worked in industry. So maybe I'll stop sharing this just for you know, I don't know, impact. So when I worked in industry, we would get plants from all over the world, and yeah, anyway, and then we would extract the RNA, because let's say that some plant in China or in the Netherlands, those plants were looking a little like with streaks on them, and oftentimes is a okay, it could be nutritional problems, but it could be a virus infecting the plant. And maybe it's a new symptom, and we don't know yet what kind of virus causes that. And so we would extract RNA, many viruses are RNA-based, and we would sequence that RNA. And then we would take that sequence that we obtained, and you threw it in BLAST. And what we were looking for is this a virus? And if it's a virus, which virus is it? So then BLAST is going through the database, and it's looking what any organism, we could actually narrow down to virus, but initially you just go like, what is this thing? And then you would get a match and you identify what is the virus that's causing this. Or you'd get no match, or the match had a really high E value, and then our conclusion was, oh, whatever this thing is still not in the database. So at that point, we couldn't identify, and then the actual work starts, right? You need to extract sap from the plant, look in the microscope, see if you can find viral particles. So, but the first step is the in silico, which is the bioinformatics step, because basically you do it from your desk and it takes a few seconds. So hopefully you found that very exciting application of BLAST, because it's very real life. One of the uses of BLAST is to identify some sample. And that was like my main use of it once I finished my PhD. All right, so this part we did. And yeah, if it doesn't match, it just means that it doesn't mean it doesn't exist. It just means nobody has uploaded that sequence to the database yet. I wonder if that still happens nowadays, because there's so much information in BLAST now. All right, so I kept telling you that the L is for local, because that was the important part, but mainly it's a cute acronym for Basic Local Alignment Search Tool. So we do the comparison of the query and gives you back a subject. And I gave you the example of identifying a sample. Another example is to find homologs. So if you guys remember, homologs are sequences that have an ancestor in common. So for example, you have this, maybe it's a gene that you have from strawberry, my favorite thing. And then you want to see, do other organisms also have this gene? So you're looking for, if I'm looking for other organisms, then I'm looking for orthologs. Maybe I want to know, is there a copy of this gene in strawberry? Then I'm looking for paralogs. But anyway, we can use BLAST to find homologs. The last one is suggest function, which is, I have this gene in strawberry. I don't know what it does in strawberry, but I could figure out what does this sequence do in some other organism, and the result of BLAST may give me some cues of what kind of enzyme or what kind of protein it encodes. And when I wrote suggest, okay, I always ask some tricky question, and like in homework, I will tell you, it will tell you what is the function when you do BLAST. BLAST doesn't tell you what that gene does in the organism you're studying, unless your match is in that same organism, but it can give you an idea. So that's the suggesting part, because the same gene can do different things in different organisms. So the orthologs often have the same function, but not necessarily. And the paralogs often have similar function, but not necessarily. So the suggesting is to tell you, it gives you an educated idea, but I'm not for sure this is what it does. For you to figure that out, you need to break that gene in the lab and see what it does to the organism you're studying. So good, so far so good. You guys there? We're going to do an exercise in 2 more slides. Thanks for answering. So I told you that there are different types of BLAST. So there is BLAST N, that's for nucleotide. BLAST P is to align protein, so it's amino acid sequence. There's something called T-BLAST N, there's one called T-BLAST X, and there's one called BLAST X. You do not have to memorize what these mean at all. Like, I think I only know these, because all of these, they tell you right on the website when you go to BLAST what it's doing. So you just need to know, what does that mean? Translated. You will do an exercise, but since you're so curious, so, well, maybe let me start with the easiest ones. This you did before. So you're given a nucleotide, and BLAST is asking, is there any nucleotide sequence that matches the nucleotide you gave it? Or you give an amino acid sequence, and then it BLAST will look at a different collection. Right now, it's going to look in my collection of amino acid sequences. Do I have anything that matches your amino acid sequence? So this is looking at a nucleotide database. This is looking at a protein database. They're separate. This one, you have protein sequence, and you are looking at a nucleotide database. And you're like, how does that happen? So that's when BLAST does a 6-frame translation, which it says, if this nucleotide sequence was a protein sequence, what 6 proteins could it be? More on that in a little bit. So, and then there are these other ones that you give a nucleotide sequence, it translates your nucleotide that you gave it, and then looks at the protein database. And then this one, it takes forever. I pretty much never run this one because it's doing a 6-frame translation of your nucleotide sequence and the 6-frame translation of all the nucleotide sequences in the database. And it says, does anything match here? Okay, here's the part where you guys are going to do something. Here's an exercise, and let's see, it's 10:38. So I'll give you until 10:43, and then we'll go over the answers for however far you got. All right, so I'll be here. Work on this first 2 questions for 5 minutes.